Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. So guys, as always, if you guys are out to this session, please make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are telling. And one more thing guys, if you are to this point, actually like it's nearly like 100 plus days, right? So please subscribe to our channel because like I hope like we are giving a content no one else in this world can give, right? So that's the thing. Okay, please subscribe to our channel because every day we are just posting a new video. And there and one more thing, in our YouTube channel there are nearly 2000 plus quizzes. Okay, just go and attend it. Okay, that's the thing. Okay, so yeah, without wasting any time, let us jump into today's session. So today's session is all about the continuation of previous session where we have introduced you how we need to evaluate the reinforcement learning algorithm. Okay, actually we have completed one thing, right? Hope anyone, if anyone just know what we have completed in evaluation of this reinforcement learning, just ping in the comment section. Okay, I will give a minute for you guys. Okay, just recall it. Okay. Okay, so we have discussed three things, right? So first is like, so I will say next two things. Okay, and let us wait for that. Okay, we are having three different things. I will explain two more things we're gonna see today. Last session we have seen one thing of evaluating this reinforcement learning. Value based and policy based are two things that are remaining. What is the thing that we have discussed? Like reward based, right? So yeah, these are the three things that we use to evaluate this reinforcement learning model, right? So reward based, value based, and policy based. Okay, let us discuss how we can evaluate this value based metrics. First is MSE, that is mean squared error. Measure the difference between predicted and actual values. Okay, model will predict a value and that is some actual value, right? What is the difference between it? That is called as mean squared error. Root mean square error, simple. Square root of mean square error, MSE, provides a more interpretable measure. Okay, just consider a way. MSE is going to find the difference between the predicted and actual result. Root of it is called as RMSE. Mean absolute error, absolute difference. It is the average absolute difference between the predicted and actual value. Okay, without considering sign. Okay, in these two methods, we're going to consider sign. Okay, that is negative sign or positive sign. In this method, we will not consider the sign. That is it. So it is called as mean absolute error. Okay. Oh, it is very simple. Okay, as we discussed for regression, I think so. So that's the same thing. Not I think so. So for regression, we have used these things. Okay, so similar to that, value-based metrics for reinforcement learning, same to that of regression metrics. Okay, so yeah, sir, over to you.
Yeah, value-based metrics there are three. Okay, we'll go and learn. One is MSE, RMSE, and MAE. Okay, so mean square error. So what is it? It measures the difference between predicted and actual value. Whatever is actual, it is going to predict that whatever the difference between predicted and actual. I'll give one example. Suppose you are predicting that tomorrow it is going to the rain will be there, but what happens that you made a prediction that rain will happen. Suppose let's say 95% or 99%. So, but what happens is the tomorrow there is no rain, or rain is little bit. You predicted, let's say, 2 inches of rain is going to fall, but then there is a, let's say, half an inch rain is there. So would you predicted the difference between half inch and 1 point or 2 inches. There's a difference, right? And that is what is mean square error, because that is the difference. Okay, so this is how, and you can apply this concept anywhere, wherever you are going to find between actual and predicted values. So that will be the measurement difference, will be mean square error. Okay, I hope you have understood it. If not, you can ask the question again. Okay, or you can give ideas. in the comment section. So root mean square error is square root of MSE. Okay, now we understand now till now that what is MSE, mean square error, right? So let us go step by step, okay, and understand that now root mean square error, RMSE, is the square root of. So now you need to understand what is square root. Square root is, you've seen that mathematical sign, okay? Like that covering some numeric under it, okay? So like, so the square root of MSE, okay, provides a more interpretable measure. Okay, it will okay, it will do RSME will do square root of MSE. That's the crux of it, and provides more interpretable measure. Okay, so that is why RSME is like it will provide that interpretation of measure. Again, it will measure the difference, but with square root of MSE. That's it. That is the only crux of this particular concept. Okay. Then mean absolute error, MAE, is average absolute difference between predicted and actual value. Now, see, in MSE, we measure the difference between predicted and actual. In RMSE, we put square root and predicted more interpretable measure. That is the difference. This is how simply you will. But in means absolute error, you do the average absolute difference between predicted and actual. So you get the average. So this is how these three concepts are unique and are used according to the situation. What is data characteristics, how is your model, what kind of algorithm you're using, what is your objective function, and all those characteristics, and then you use it, these matrix, okay, value-based matrix. These are the value-based metrics, and they are going to help us. So to understand, one is we understand data. Second is algorithm will predict, make better model based on these techniques. Okay. There are two things, guys, you have to understand. First is, as a data scientist, as an AI researcher, we have to understand things. Second is, model has to understand and make predictions and make decisions. These are two things, because both of us need to understand things properly. Then your model will perform excellent ways. Okay, so let's move to the other section.
Yeah, sure, sir. So, guys, we have completed reward based, value based. Let's move on to the next thing. Okay, let's see what we are having next. Policy based, right? Simple. We are having policy based. Okay, what is policy based metric? Success rate, percentage of episodes where the agent reaches a desired goal. Okay, that is called a success rate. How many episodes? That is, we can say it like, okay, this from 100 episodes, this much of episode the agent can able to reach the desired result. That is called a success rate percentage. Then time to completion, average number of steps taken to reach the goal. Okay, that is how many steps that a agent takes in order to reach the goal. That is called as time to completion. Win rate, percentage of games won against the specific opponent. That's it. Okay, we're gonna have an opponent and they're gonna be our agent. How many times a specific win? That is called as win rate. So these are the some of the metrics which is under this policy based metrics. Okay, success rate, time to completion, and win rate. Okay, I hope like this is very simple English. Okay, very simple English. Okay, so I hope like you guys can able to understand. Yes, sir. Over to you.
Yes, so policy-based metrics is like, you guys know what is policy. So policy is set of instructions that agent has to plan, has to make decisions, okay, whatever is the objective function till the time we reach human level intelligence, which is called artificial general intelligence, or super intelligence, which is called super intelligence, which is above human beings. So till that time, we are always working in a narrow AI, which is called as per objective function. We don't make models for everything, okay? Solve all problems. We make models to solve the specific problems, okay? So policy based is whatever are the instructions given to solve an objective function, what specific task agent has to perform or bot has to perform in a manner, or trained on a different data and then performs. It depends, okay, what is your objective function. So success rate, percentage of episodes where the agent reaches a desired goal. So this is what it means specifically, guys. Success rate. The agent reaches a desired goal. That is success rate here. It is not your general success rate, what we call normally success rate. Here, it is specifically agent reaches a desired goal as per the objective function. Then time to completion is average number of steps taken to reach the goal. Okay, that is like average number of steps taken to reach the goal. Even if you see Indian cricket team or any cricket team in the world, they win matches because of averages, guys. If you manage average, and so, see, somebody is driving at 120 speed, okay? I'll give you a very basic example, real life example. Somebody is driving at 120 speed and suddenly he goes to 60, suddenly he goes to 40, suddenly he goes to, and car gets damaged, he loses for an hour, he is not able to perform, okay? And if you see the average of that person, it is not it won't be more than 50. And there is a person whose average is 70, he is going to win because even his average is 51. I'm saying he will win because he maintained the average. And time is always, productivity is not into doing big things, but doing small things and continuously with consistency and persistency, continuously doing, okay? And then average matters, okay? So average number of steps taken to reach the goal. Average really matters, guys. There's a law of average, law of large numbers, that also is based on average, guys, okay? So we also, when we go to buy a good car, we'll say what is the average mileage, we'll say that. So average is it's a fantastic tool. I'll say it's a very like best technique, okay? Even when we see data, we always see what is mean. Mean is average of your plus and minus, standard deviation, right? We see average. So we make decision based on average. I'm telling you, if you understand average, you understand stat, because if data is right, then you find a right average, you make decisions. Don't use fancy things and techniques. If you understand average properly, you understood stat, I think 90% you will understand. Then there are different techniques, okay? Time to complete. I'm just taking further the concept so that you will absorb it, okay? Then win rate, percentage of game won against a specific opponent. Percentage of games won against a specific win rate. Again, if you see, win rate is kind of average, because in a specific, when you're playing game against a specific opponent, what is the rate you are winning, okay? Again, that if you do math of it, you will come to average only. For a specific opponent, what is the average? For a specific opponent, what is the average? For this or that or X or Y. So this is what is win rate, okay? So these are three components which are going to help you to understand policy-based metrics. So it is when policy is made, the instructions for the agent or any technology or algorithm or model you're creating. So these are very important factors. So keep in mind when you are developing the model. Let's go to the other side.
Yeah, sure, sir. So actually, like it's a very basic and elaborate explanation. Thank you so much, sir. So yeah, let us move on to the next slide. Okay. So let's see what we are having next. Okay, multi-objective evaluation. Okay, so it is another way. Okay, because we have seen a basic way how we can evaluate this uh, reinforcement learning techniques, right? Reward based, policy based, and then something like uh, what are the things that we are having, we are just learning. Okay, now we're gonna see something out of it. Okay, that is multi-objective evaluation. Okay, so now there are going to be something different. Okay, let's see what we are having. Okay, Pareto optimization, that means finding a set of solutions where no objective can be improved without satisfying another. Okay, sacrificing another. Okay, the thing is here we're gonna find a set of solutions. Okay, whose objective cannot be attained without certain conditions. That is called as Pareto optimization. Then we are having something called as weighted sum, combining multiple objectives into a single score using weights. Okay, so weighted sum is a simple thing. Okay, we're gonna have lots of objectives for a single problem. We're gonna sum it up and we're gonna get a single value, right? That is called as weight. Okay, the value which we get after summing up is called as weight. Hypervolume measures the volume of the space dominated by the solutions. Okay, that means here the space, like space means the environment where the agent acts. So we're going to measure how much our solution able us makes our agent to work on the environment. That is called as hypervolume. Okay, so these are something which is out of the basic evaluation that we are having for reinforcement learning, that like Pareto optimization, weighted sum, and then hypervolume. Okay, so yes sir, over to you.
Yeah. So let us go to multi-objective evaluation. So we have these components. One is Pareto optimization, finding set of solutions where no objective can be improved without sacrificing the another. Okay, this is one technique. Then weighted sum, combining multiple objectives into a single score using weightage. Okay, then we have hyper volume, measures the volume of the space that okay dominated by the solution. So these are three objective evaluation. That's why it is called multi-objective evaluation. So you need to understand the concept deeply so that you can build knowledge body deeply and apply them in the application part. So absorb the information, digest and apply. So have persistency, consistency, and patience, and perseverance, and long-term objective function, what you want to become. So keep learning deeply, guys. Let's move to the other section.
Yeah, sure, sir. Okay, let's see what we are having next. Okay, selecting the right evaluation metrics. Okay, we have seen lots of metrics, right? The base version and then the advanced version. Okay, how to select the proper and right evaluation metrics. Problem type, consider the nature of the task and the desired outcome. Okay, first of all, we need to choose what is our task and what is going to be our solution. That was the first thing. Domain knowledge, leverage the insights from the specific domain to choose relevant metrics. Yeah, that is very, very important, guys. Okay, as a data scientist, we need to have a domain knowledge. Okay, so wherever you work, okay, it can be a medical domain, it can be embedded system, it can be like a marketing, finance, anything. Okay, there should be a part of domain knowledge you guys need to have. Then only you can apply your data science skill there. That is also one of the metrics that we need in order to choose the right evaluation metrics. Model architecture, select metrics that align with the chosen model architecture, because like if you choose a reinforcement learning architecture, then go and use only reinforcement learning related metrics. Don't go and use something which is different like clustering metrics or a classification. No, use a metrics that is defined for the architecture. Okay, so problem type, domain knowledge, and then model architectures are the way that you can select a right evaluation metrics. Okay, hope you guys can able to understand, right? If you guys doesn't able to understand, please make sure that you guys put your doubts in the comment section. We will take up and we will solve your doubts. Okay, so yeah, sir, over to you.
So, selecting the right evaluation metrics, problem type, first we need to consider that, considering nature of the task and desired outcome. That is why I have been reiterating that you have to understand the problem. Okay, what is the problem type? When you are going selecting right evaluation metrics, so you need to understand deeply, like nobody else should understand. That is why you will be called data scientist, guys. I'll not call somebody data scientist because he knows stats. I'll call data scientist somebody who understands problem deeply and the data and the model and the process, and then communicates it effectively to the stakeholders, okay, or a AI researcher. So consider the nature of the task and the desired outcome. So objective function. So once you understand nature of the problem type, right, considering nature of the task, that means understanding problem deeply, and the desired outcome, what is the objective function of what you're going to solve. It is problem, understanding it and solving what is the objective function, and collecting data and cleaning, pre-processing, EDA, finding algorithm, finding right evaluation metric, everything, and then selecting right algorithm, and then building prototype and solution for it, and then building model and deploying it, and creating world-class service or product, something. So domain knowledge, that is very very important, because you can't. So domain knowledge, either you are in the domain or you need to take, like, leverage insights from the specific domain to choose relevant methods. You need to consult with the people who are in the domain, okay, who are in that particular field, and they've spent 10, 20, 30 years or generations of knowledge. So that domain expertise is very very important. So leveraging insights from the specific domain to choose relevant metrics, that is very important. Then model architect, selecting metric that aligns with the chosen model architect, that is very very. So for that, understanding each and every element specifically, guys, end to end, then and only you will be able to model architect, you will be able to align with the model architect. When you understand end to end specifically each and everything, you need to document, and you need to have consciousness and awareness about each and every element of end to end, what you're going to build, what is the problem, which algorithm. So you can only have that when you holistically understand AI, ML, data science, and deep learning and generative AI, and all the latest upcoming trends in AI, ML. Let's move to the other section.
Sure, sir. Okay. Let's move on to the next thing. Okay. Yeah. Conclusion and future direction, guys. Actually, we are completing this reinforcement learning. Okay. What is the conclusion and future direction? Effective evaluation is critical for the advancement of oral. That is reinforcement learning. Future research should focus on developing new metrics for complex tasks such as multi-agent system and continuous control. Okay. It's not a future, we are doing in a present thing. Okay, so for a multi-agent system we are doing these things, it's a present thing. Okay, so yeah, that is what the conclusion and future direction for this evaluation of our RM. Okay, so yeah, sir, over to you.
Conclusion and future directions. So here are effective evaluation criteria for the advancement of ARL. Future research should be focused on developing new metrics for complex tasks such as multi-agent systems and continuous control. So these are very, very important things. Like it is very critical for advancement of RL and future research, and we need to continuously learn and be updated. Okay, we need to understand continuously how these multi-agent systems, and we need to also understand the continuous control of these technologies and RL especially. So these are very cool technologies and algorithms. So they are going to help us, but we need to continuously develop and keep eye on the future research. Okay, and we can also develop algorithms. Okay, for these this particular specific domain, we can do that. But for that, we need to understand holistically, have a deep understanding about the concepts. Okay, let's conclude this particular section. Thanks.
Yeah, guys. So we have done with reinforcement learning. Okay, last part also we have done, and you gonna see a surprise. Okay, in the next session we're gonna see a coding part of reinforcement learning, guys. It's not gonna be like more than 15 lines. Okay, it's gonna be only 10 to 15 lines. Okay, and the next session is not gonna take more than 10 minutes. It's guaranteed, guys. Okay, so yeah, we will all meet in that interesting session of coding part of this reinforcement learning. Until next session, guys. Bye. Take care. We will all meet in the next session. Bye, guys.